So today we're talking about feature engineering, and I'll explain to you what this means. But it's an important step in the data science process. And it's a very important step because this is basically your gateway into proper machine learning, making models. We learned about what models are, but let's do a recap first, right? So it's the core idea of what a model is that we have a bunch of data, and then we, at least the data-driven models that we talked about, and we build some models out of it, and then we do some sort of prediction, I don't know, classification. We might do hypothesis testing. In Colab, you can mount yes, you can upload it and that'll disappear. You can mount. The mounting Google Drive is the best option for using Google Colab. That's what I do. But then if you end up submitting a code, do not give us mounting code. That is for you and you only. Simple code, like, that's why I uploaded here, because this looks like using a local Jupyter notebook this way. Does that answer your question? Okay, there we go. So yeah, we just went through this. You can go back to the video. Essentially, the idea is that there are different types of models, but we generally prepare the data for it, right? That's what we call this process of building models from data. You can do also different things with it. And this is not the list is not exhaustive, right? A tabular data set might look like this, right? This is the CSV that I've shared with you. I might have a video ID. This is not the whole thing, but the title, that's just text, a category with either text in a categorical data formats that we've talked about. Then we have a temporal date type of data. Then we have numerical values, right? So these are different ways that we understand the data and we store the data. Okay? Our mathematical models, which is basically anything that we do in this class, in data science in general, do not understand these strings or anything else besides numbers. All that we do before we build any model is transform somehow the columns, the data, into some sort of numerical format, a vector. They all need to be translated, right? Something like this. You need this before you can do your training. All of your ChatGPT work, everything that you do with any AI model there is a process that goes through this. This is fed into the model. Then there is a reverse process. So there's this encoding, decoding process. Okay? This is very important to remember. Basically, feature engineering, one part of it is this. You need to turn your data that's suitable for humans to machine model readable data sets. Okay? So like, for example, you can get this category into some sort of vector like this. You can say, okay, mid is 1. You can say Saturday, make it is weekend Boolean 0 and 1. You can turn a duration and keep it, or you can scale it. At the end of the day, you want to translate that into a model like this. So every row in the data set becomes a vector like this. The model sees only these numbers, nothing else, right? You have then external things that translate, that keeps the order, the way you feed the data to your model and back to your system. And feature engineering is the process of building this vector, right? It's not all of it, because feature engineering is also getting rid of the features that you don't want, right? For example, look at this, right? We have title, we have category, and if you want to predict view count before a video goes out, if our data set has likes and comments, we don't want to use this. In the real world, before the video is published, you're not going to have likes or comments, right? So it's problematic. Essentially leak the future into the model. The prediction will look great. This will really affect your prediction, but it's in practice is useless. Another reason is that two features might correlate with each other. And if that's the case, then your prediction model is not doing anything. That feature is running everything. You want to learn from these different things. Okay? So the idea is that transforming the raw data into vector of numbers a model can learn from while choosing the right features for the question being asked. That's how I think about feature engineering. There's a lot of different ways you do this. If you have a image model, you turn it into numbers. There's the process of doing that, right? If you have text, you do this. Now we're going to look at text a little bit. Any of you who've done AI course or you're taking it, you'll do more of this, right? So the idea is that you do feature engineering that gets you to a feature vector, and then you feed that to the model. This is the process. This is the part that requires human thinking sometimes. So let's learn some feature engineering ideas. These are different techniques, regardless of what model you're going to train, which we are going to. I believe Mehdi will show you just a linear regression today, right? We're going to learn more and more of these types of models. You will do this, okay? So you will have to, as a data scientist, you will have to do a lot of these stuff. Even if you ask AI to do it for you, you will need to know what types of transformations you might need, because some things are important for your domain and some things are not. So the first idea is scaling and normalization. We've already seen this in our math section. So you want to put features on a common scale so the model treats them fairly. If some columns are different, like it's like 2000 from 0 to a million, the other is from 0 to 1. Again, if you know a little bit of vector algebra, that is influencing your vector in a way that it shouldn't. Because at the end of the day, most of what we do is linear algebra, vectors and matrices. They're being multiplied to each other and stuff. There's something happening. If that number is just overblown, it's going to be influencing. Okay, so one of the first things that we do is min-max scaling. That was the idea. Different features live on completely different scales, right? So for example, duration in seconds might go from 120 to 14,000. Click-through rate could go from 0.101 to 0.25, and then subscribers could go from 5,000 to 8,000. So the way you want to think about this is that you somehow translate this to a common scale, maybe 0 to 1. A lot of times this is a good idea. And then you later, if you want to understand what the output is and whether you need somewhere back, you have also a function that gets this 0 to 1 into this. So this is like a linear transformation, usually. The min-max scaling, that's what it is. Okay? And then you do this for a lot of these. So you want to take the minimum, the maximum, whatever number fits between these. If you get the minimum, you get 0. If you put the maximum, and anything else is linearly distributed. So that's what I would just basically talked about. If you see subscribers, this will overwhelm. The numbers are bigger. The idea of min-max scaling is very simple. You get the difference between the number and the minimum, and then divided by the range. You divide it by the maximum and the minimum, and you get a value between 0 and 1. So let's try this in our data set. Subscribers range from 5K to 8 million, depending on channel tier. Raw, it dominates any distance-based models. Okay, so we want to now translate these to 0, 1. In the slides, I put a lot of code for you. Okay, dang. I clicked. So I put a code for you. And in the lecture, I'll show you what the core ideas is, and we'll practice it together. From now on, a lot of the work is simpler than what we teach in the slides, because you run a scikit-learn function and it's one line, even though we show you formulas. So it's really important to learn the intuition behind these, okay? So here, let's try this. What we want to do is to create a scalar. So these are the two lines that you need, okay? And let's write the code, and you should follow along with me. Okay, so what I want to do is essentially import what you need from scikit-learn. So from sklearn.preprocessing, import min max scalar. That is, apologies. Yeah, this is what you want to import. Now you have access to this min max scalar. Okay? You're going to repeat this process many times. Okay? In scikit-learn, this is how you do something. You say, okay, you build your scalar object, min max scalar. So you run it. Now you have access to the scalar object. The scalar object has a fit method, a fit transform method, and other things. Okay, this is also a model. It's a very simple model. Okay, so what you want to do is to get subscribers, right? Let's look at it. Let's run a code. You say df subscribers. These are all the different numbers. Scikit-learn makes it really easy for you. You go df, you go scalar.fit transform, and then you pass df subscribers to it. You need to pass, this needs to be a vector, so this is how you do it. Okay, now you can set this to df, let's say subscribers min max equals that, and that sets it for you. Subscribers min max is now a column where you get the min max values. How do we know it's actually happened? Let's see. You go df subscribers describe. So what's the minimum? It's the minimum number. Now it's show you, but it's the minimum number here. The maximum is the maximum number here, and then everything else is the same. So you've now done it. You have created a min-max version between 0 to 1. Oh, we need to get the min-max. My brain. So the minimum should be 0. I was like, how is this minimum not 0? And then I realized, so yeah, the minimum is 0, the maximum is 1, and everything else. So now you have transformed this into the same thing. Okay, so you have the code here. Yeah. I think the reason is that you wanna get the input that fit transform needs is a vector of vectors or something. So it needs subscribers to be inside square brackets. With the imports, so okay, yeah, but when you should pip install scikit-learn. If you installed Anaconda, you should already have it. Like here, like for this time, go to these slides and you can copy and paste code from it. See, maybe you have a typo, but please don't copy and paste from the code. This is for your reference later. So you can have some code somewhere in your slides easily. But yeah, I think that's probably the reason. You probably have scikit-learn. Anyways, no problem. Anyways, and if you draw so here the rest of the code is just drawing histograms of these, and you see the shape is the same, right? The only difference is that the minimum here is like the maximum is like a large number. Here, the maximum is 1. That's it. So you squish the data into a common format, and you can run this on multiple columns. Okay, So now just, again, this is going to be probably like super easy from now on because scikit-learn has done most of the work. Look at the data, run this on another column, and just see the results and plot it for yourself with a histogram or something. This should be super quick. I'm going to give you a couple of minutes because this, again, literally fit transform, just change this column to whatever else you want. It should be numerical. You can do duration or anything. Even though this might sound not like as profound of a method, this is really useful. It's linear transformation is generally one of the most used ways of scaling data. Okay. Hope you all have done it. Okay, so what's next? We have seen this before. Now, instead of min-maxing, right, going from minimum to maximum to 0, 1, so it's transferring, you can say, okay, how far is each number from the mean? And then calculate the score. This is called the z-score or z-score, as Canadians put it. So essentially, you're creating a data around mean 0 and scales by the standard deviation. Okay, so let's look at views now. Min-max would compress 95% of videos into a tiny range. So for the different types of data, you don't want to use min-max when there's like really large values. You might use z-score. You essentially center them around 0, and then most would sit between -1 and 2, and then outlier clearly visible behind that, right? Again, boom, another pre-processing function for this z-score. Again, we've already seen what z-score is. So you go, I believe it's called standard scaler. So you import it, and then you go, you make standard scaler, or you can just, and then you can say df view z-score equals standard scaler dot fit transform df view count, I believe, or views. So you can essentially do a summary of now your data set, pass views, and then do view z-score, and then call describe on it. View, there's no s. So you can see that now the minimum is like some negative number and the maximum is a positive number, and they are around 0. So how does it look like? Again, it's preserving the shape. However, pay attention to this. Now 0 is here, because it mattered how big the numbers are, right? The shape is important, but how big the numbers are important. Now, a lot of your data is negative. You have like the maximum value is 5 standard deviations away from the mean. So you get a really nice information on what your data said. Okay? It's going to be pretty repetitive, the coding. So for these scaling ones, I'm not going to repeat. Just get that intuition and learn how to use it. So again, scalar dot fit transform. That's all you need to do, but you just need to choose what scalar you're using. And then these formulas, if you're like nerd or something, you can build it for yourself, right? You can try to run this. These are really simple functions that you can try to create yourself as well. Anyways, there's the, because z-scores use the mean and pull the outliers, pull them, you can use robust scaling, which uses the median and interquartile ranges. So you can go the number minus median divided by the IQR will give you the value, the score that you need, right? So you can do the same thing with robust scaling, right? You can get like negative values, but not as big. So surprise, surprise, robust scalar is what you need to call. Dot fit transform views, You can plot it. Its code is here. It's just a different scale. You basically, you need to see what distribution. So we've learned about exploratory data visualization, right? You need to see what features your data has, your variable has, and see how you need to scale it. Depends on the data. Okay. So now I have a task for you. We tried robust scaling, we tried Z-score, we tried min-max. Okay? And you run min-max on one thing. So go to the data set, run each of these once on a different column. The only thing that you need to have is, you can run it on views or likes or comments. The only thing that you need to have is not run it on a string data set that's the values are strings, okay? And you know that you will submit these as a sort of lab participation. No, just use the same data set, but use different columns. I just want you to run it once. I didn't want to just run 3 times. No, min-max, robust scaling, and standard scaler. Look it up. If you want to see what the function is, look it up. I'll be right back. Do we need to plot histograms too? Just plot it for one of them. Seaborn makes it really easy. SNS.histplot. Okay? Are we all done? Thumbs up if you're done. So robust scaling. Okay, I'll wait. Min-max scaling. Standard scaling. All right. If you're not done, put a note to yourself, finish it after the class. I hope everyone is done though. That's simple. Okay, we've extensively looked at logarithms and why we use them, right? But in general, many real-world variables grow exponentially. A small number of cases dominate the range. It compresses everything else to the left or to, okay? So what you do, in many cases, you take the log of that value. You do +1 if you have 0 in your data set, because you can't have log of 0. But if there are no zeros, so you can skip the +1. Very simple. This is a transfer, okay? Or you're just getting much less spread. So these 3 variables, views, subscribers, and watch time minutes, are heavily right skewed. So we can look at it. Yeah, we can take it from 7 million to 8 log units. This is a bit different, so let's look at it. So we can say df views log equals numpy, and then I need to import numpy as np. This is the one that adds 1 to the value, and then you can just get the views. df views log. So now we're going to visualize it. So let me just import Seaborn, and then I can just go sns.histplot df views log. Okay? This is unrelated. This just sets a style to make. I've shown this to you in the visualization class, but you can set this style using Seaborn. Look it up. There's different named styles. So this is the transformed, and then if you just look at views, you can see how different it is. Okay? So you're taking the log and then transforming it. We have the code here. This is how it looks like. I told you which features are right skewed, so run it. Just get into the habit of running code, typing. So watch time minutes, just type. Run this. Create a new column. Very easy. Okay. How are we looking? Should you do thumbs up if you've done a log transform? Very simple, 1 line. Where is it? Thank you all. Okay, let's move forward. Another thing is binning. We've already seen binning again. So sometimes the continuous number is less meaningful for us. A model predicting engagement doesn't need to know video is exactly, sometimes, maybe, it doesn't need to know if it's 743 seconds. Maybe it needs to know medium length. Okay, maybe you can do that. So you can essentially bin. That's a way of grouping data if you need to do that. You need to know to have domain knowledge to define meaningful ranges. It might reduce noise for you. Can reduce a nonlinear relationship linear. You'll lose information, obviously, and sometimes the exact values matter. Okay, so you want to maybe think about when you need to bin. A lot of time binning, a useful binning, which is a binary binning, because you don't need to use any sort of technical binning, but you can say if it's less than something or more than something. For example, for housing prices, houses that are less than $1 million and more, it's much different. You can have a number where it's affordable for people. You know what I'm saying? So you can just use that as a binning technique, or you can get some sort of median way to bin numbers. But the idea of binning is to take a numerical value and make it into a categorical. That's the whole thing. Okay? So we can encode duration bin as a categorical feature, or use it directly as a grouping variable in an analysis. So how do we bin? I can show you. So if you're not doing equal bins, you need to define them. So you can say bins equals, let's say 0, 300, 2000, and then you can just say infinity. Everything else is afterwards. You can have labels for it. You can say short, medium, and long. Okay? Very simply, you just go duration bin, and this now we're not even using scikit-learn. Pandas has it. It's called PD cut boom. Duration is the duration, but you need to add seconds to it. The bins is bins, and labels is labels. You can create a count plot because it's categorical and see this. Histogram is basically doing the same technique, but with equal bin sizes. Okay, you should bin a column, but you have a little work to do. You can think about, I want to see what categories you create. This is a little bit more fun. So let's try between likes, comments, shares. You can choose your own bins and give your own labels, and then just send the bar chart on the Discord, because we're almost done with the numerical stuff. Mehdi, I think your session will be probably left for tomorrow.
Yeah, I was also looking at the number of the pages of the slides we've covered so far. So
Yeah.
I think we are like halfway there.
Yeah.
And since we have 40 minutes, 50 minutes left, I think I'm gonna do it tomorrow.
Yeah. Yes, between the columns of likes, comments, and shares, choose. But choose your own bins. And then we're going to create a thread here. I created a bin, visual thread into the lecture slides. You should put your bar plots over there. All you need to do is these 3 lines for a new column. I just want to see what number. Just try to pick a reasonable number. So you need to see the minimum, the maximum. So use describe to see your data, and then pick reasonable numbers, reasonable labels, and see what you use. Okay? You just need to pick one of them. All right, Michael's got it. Let's see. I'm going to bring it here. Irrelevant 20 seconds of fame meme status. Okay. Is this based on what are the bins though? Oh, how many likes? What were the bin thresholds? 0, 100 is, oh, and then 3,000. Okay. More than 3,000 is meme status. 20 seconds of fame between 100 and 3,000, irrelevant. All of the videos for this class are irrelevant based on Michael's binning technique because we get 2 likes. You don't, I should in the class say hit the thumbs up button because you guys don't do it. Any other videos? Or you don't know where the YouTube is? I was gonna cry. I was like, the links are in the class. Every video is posted. I'm trying to be so organized. Thanks. I'm trying to be not a super organized person, but I'm really trying. Okay. Any other bar plots? Anyone figured out a binning? Okay, let's look at Tim. So we're looking at shares. Cool. What were the thresholds? The bin? Perfect. Okay. I think that's good. Everyone else, you'll okay, let's look at the last one. We have niche, trending, viral, meme, Vine level. What's Vine? Vine isn't Vine that old? What is Vine? Is it like that old app that used to? Am I just a boomer who don't know what Vine is? Oh, okay. Sounds good. The old app sounds good. Yeah, you got it. Yeah, we miss it, man. I know. Okay, cool. This is great. So you all have examples of how binning works. Let's move forward. We're moving to a very important. Up till here, if you fed your numbers to a model, it wouldn't complain. It would build a model for you. Your model would be bad. With categorical values, the model cannot even interpret them, right? The strings, it's not useful. So the first thing is ordinal encoding. So when the categorical value has a natural order, you treat them as basically they're arbitrary labels, throw that information away, right? So for example, you go small, mid, large, you can treat it as 0, 1, 2. So channel tier here has a clear ordering. Small channels have fewer subscribers, less reach, and typically fewer views than mid and large. The model should know that, right? So you want to transform it using this format. Okay? We are going to do a very simple thing with scikit-learn ordinal encoder. So I can say encoder equals ordinal encoder. You want to give it the categories now. So you can give it the categories equals like small, medium, and large. Very much like everything else. You can say channel here encoded, and then you will close this string, and you can also here it'll give you a floating number. You can just get it as a string, as an integer. So I should make sure these values should match the strings that you have. So you do small, mid, and large. You should essentially, you should not do it like me. You should go df channel here unique, and then just copy and paste. Don't be like the person who's teaching you. Okay, now this should work. You can see now that everything is 0, 1, or 2. You can see that we can just see channel here. So mid would, oh, I also messed up. because mid is first, it put mid as 0. So don't mess up like I did. So you should, the ordering is important. So you do like this. You repeat. Now mid is 1, small is 0, large is 2. Very easy. And so essentially, small, mid, large goes to 0, 1, and 2. Okay? Another very important technique, one hot encoding, or they call it dummy variables. Why? So when categories have no natural order, assigning integers is misleading. Is gaming equals 3 really greater than music equals 1, for example? The model would think so. So what would you do? You create for each of the categories a new column. For example, if the category was tutorial, then the column tutorial would be 1, everything else would be 0. Review, same. Debate and controversy, same. This is called one hot encoding, or creating dummy variables. So category has 6 unordered values, right? You want to get these into this sort of format. You get a lot of columns, your vector is going to get large, but this is the way to do it. A lot of times you do want to create categorical values, right? And this is how, let's say you want to create a linear regression and one of your data that you created is this. You can, but you should first turn that into this. Okay? All right, so dummy vars equals, let me just copy and paste, pd.getDummies, and then you pass the column that you need, and then, so let's look at it. False, false, true, false. And in computers, true and false is technically 0 and 1, so you're good. It's not, this is, Boolean is okay. And then you can add this, you can concatenate. You can say, let's say df equals pd.concat, then df and dummy vars. And then you got to say access equals 1. I'm overriding on df, right? So now your data frame has all these new columns. You can now, instead of, you will never be able to use this as a feature, but now you have engineered new features. You're going to do this a lot. One hot encoding or dummy variables. If any of you gets any sort of research job or stats job or anything, this is something that you will do a lot. Okay, you don't have to repeat this. I want to show you date and time. Mehdi will have a lot more examples here, right? But let me just show you. Again, I'm not going to spend time writing code. First of all, with a day and with an hour, you can get this sort of, whether it's weekend or not, whether it's prime time or not, you can do this. So you don't want to get Saturday in your data set. You want to get the number, whether it's a weekend, some sort of variables, right? Or you can get the order, the day number, or the week number, or everything. I did not have the actual timestamp. Do you have timestamp in your data set? Mehdi?
Yes, I do have
Okay,
timestamps, yeah.
then. I'm creating it here. You can try it. So I'm just randomly creating timestamps so I can show you how it's done. Essentially, if you have a timestamp, let me just create it so you see how it looks like. Let's just use this so you can see how a timestamp looks like. Okay, so let's look at the uploaded at. A timestamp is a format that includes everything. Yes. It's in the, yeah, but you can go to the, use this here, but you can just also go to the slides. Slides are, I pasted the link for you and copy and paste from there. Okay. Now, this is a timestamp. Okay, you now have access to a lot of special functions that allows you to extract information from this. So again, let's just say day of week. You can look at, there's a ton of functions for handling dates. It's a tough thing. Honest, sometimes handling dates, and you saw an example, some examples in your explorations and findings. So by doing .dt, .day of week, you can extract that information from it, because you don't want to use this, you want to use this. Okay? When it's meaningful. Let's say you want to look at flights. Flights on Saturdays are, it's a feature, right? So, or the season is important. So you extract the season for it, right? Dates are interesting and meaningful. Anyways, you have examples here that you can look at. So we can get is weekend, and then you can treat it later essentially as with a conditional, you can get that value. Okay, we're going to do a lot of text later, but let me just show you the idea behind text analysis and encoding text data. Now we're getting to unstructured data territories. What do you think is interesting in these three? Anyone? Sure? What else? Clickbait. There you go. Sudden caps. If you open my YouTube, let's see. This is the most prevalent thing, I think. Everything has it, right? See, especially political stuff. Is a trillionaire. It's like they're yelling at your face. Reacts to, right? It just gets some sort of elicits some sort of emotion for you from you. Dog walks, PBD, so hard. So everything. This guy is yelling crazily. Okay. All right, back to here. So it's interesting, right? This is based on domain knowledge, right? You might want to just count some occurrence of something in your text. And that's feature engineering. You want to get the count of caps, and that might be a measure of whether this is clickbait, or it could predict views, because clickbait, and I sometimes try, it does not translate to views for me, but I try to use these strategies. Okay? So this pattern within text carries signal, and this is like a domain knowledge feature. Okay? Let's just run, see how you might do it. So we have in our data frame all these texts, right? So this is a very important Panda skill that you can use, is apply. Okay? With apply, you can run an anonymous function on every column. Okay? On every row, value in the row, and then return a value, put it in the column that you want. So let's see how we can do that. I want to say df caps count, right? You can just say lambda. This is a Python anonymous function, is lambda. And then you say T for text. And then this is list comprehension. So you can go 1 for word in t.split. So you're splitting the text. So let's just run this. I'll explain to you in a for loop as well. If W is upper, this one-liner, and if you learn these one-liners, it's gonna save you a lot of time. Gets you the count of caps. Okay, but now let's create count caps function. T is the text. This is essentially the same thing, right? And then you say, let's just say sum equals 0. This is like a basic way of doing this, right? So you initialize a number, and then you can go words equals t dot split. So you get the word, and then you say for word in words, then what do? Say if word is upper, sum equals sum plus 1, right? And then you go return sum. This function is the exact thing that we just try to do here. So you can actually just take this whole thing and just put count caps without calling it. I believe it should work. So let's see, it gets you the same idea. What apply is doing is taking a function as passing every row to it, the value to it, and then returning giving you the return value. So here's how you do this. Don't worry, I will also give you the code. There's a Jupyter notebook that I'll share with you. Okay? Do you think number of lowercase matters? You can count it, right? Can you guess what the lowercase is? It's probably something like this. Lambda t, sum, 1 for c, 1 for t, 1 for w in t dot split. If w is lower, lower count, and then you can see the lower count as well. You have 6 lowercase. If it matters to you, you can do that. That's one way of calculating values. Okay. Now, what if we want to do the whole thing? We're going to create a vector of text. The core idea, the very first thing that you can do is to create an ordered list of words. So of all the words in all of your documents. So you can say I, then you can have a column for tested, right? And then you can have a column for ChatGPT, and then Gemini, and then ChatGPT exists, so you don't have to write it again. Then you have the word is and the word amazing. So these are all the words. And then to turn this into a vector, you just say, okay, I happened once, tested happened once, and ChatGPT happened once. Everything else is 0. That's how you turn this into a count vector. Okay? Very simply. Each row now is a vector of numbers. However, these I, the, is, these are not meaningful information, right? So you want to find a way to not include this in your metric. So you want to say, okay, do I care about I? How do I decide? Okay? Because I appears in 2 out of 3 documents. It tells us nothing about what makes each title distinctive, right? So you want a way to reward rare, meaningful words. So what we do is sometimes is a technique called TF. IDF is here, is not that the famous IDF is inverse document frequency, and TF is term frequency. You don't need to memorize this, but the idea is that you get the total documents and then the number of documents containing the term T, and then you multiply that, but you take the log of it and then you multiply that by the frequency of it. Okay? What this gives you, it basically, if the word happens many times, the denominator is going to be larger, the value is going to be smaller, is going to give you not as much information here. So a word that appears in every document gets the IDF of 0, so it contributes nothing. Okay? So I'm not going to repeat this. You can run this code. Oh, dang, every time. To get your TF IDF vector from any string, it can create it for you. It can also get you number of features. You then create a vectorizer from feature extraction. Now we're doing feature extraction from text. And then we're going to do this later, but just look at this later. And then you can get a score for each word in your document. So refer to these slides. And for your task, just run this code. Just take this code and run it on your data set. That's all you need to do. Okay. Lastly, I think this is I believe this is the last one, almost. We also can combine features, right? To reveal relationships in a model can't see on its own, right? So for example, raw counts don't tell us the full story. For example, a video with 10,000 comments means something very different with 100K views versus 10 million views, right? This number, essentially, instead of getting the total number, you need to calculate a ratio. Ratio is simple. You get the watch time in minutes divided by duration in minutes, okay? And this gets you a retention rate, a meaningful value for how much of that video, total video that you got, people are watching. It's a retention rate for each video. So one person watched 0.9, one person 5.4. This is a meaningful number. And you can get a sense of how much that is meaningful for you. I have the code here. I want to give time because I know a lot of people don't show up on Tuesday. I'm rushing through these because I want Mehdi to show you that and the beginning of, is that okay, Mehdi? Or do you think a video announcement would be fine? Whichever you say.
For the lab tomorrow?
Just the data. So for the people that who cannot show up, they have the beginning. Should we do that?
I will record the whole
Okay,
lab.
then. Okay, then
Yeah.
we can do this tomorrow anyways. Cool. So yeah, retention rate is simple. It's just a division. I'm just gonna, actually, let's just do the retention rate then now that we're good. So I'm just gonna say DF retention rate equals DF watch time minutes divided by views times DF duration minutes. Okay? And we don't have duration minutes, so you have to calculate that as well. Another simple feature engineering. You can duration seconds divided by 60. And then you have your retention rate. For the ones that I told you to run it with your own column, you should. Everything else, I just want to see a complete Jupyter notebook run. Simply. Because with the other lab, which is going to have, I think you should submit this tonight because tomorrow you're going to have a larger project that takes a few days. Mehdi will show you, but submitting it will have it's going to be more things to do. It's more specific. It's a really interesting task that he's created. And here's how retention rate looks like. Lastly, tomorrow is another lab. Is a continuation of feature engineering. I'm showing you concepts. You're going to go through another example with another data set that's like a more coherent. You're just looking at a more real. I'm trying to show you everything. That example doesn't show everything, but it's like a realistic example. This is the motto of this class. We're going to repeat things so many times that y'all remember and learn a portion of the class, right? This is how we're going to practice together. Okay, the last thing is you sometimes multiply columns together to get something. So like subscribers divided by the click-through rate is your reach potential, for example, right? Very simple idea. I don't want to go through it much. You can get mid-tier, high-tier. You can combine them. You can multiply two columns together. I'm not going to, so you can just go column 1 star column 2. This is NumPy. You can multiply those numbers together. It'll do it. It's simple. And you get these different values. Sometimes you need to do this. Sometimes you need to sum values. If you run a survey, there are scales. Let's say they tell you, okay, I ran a survey with 10 items. The score is the sum of all of those items. So you just take the sum of all those columns, and that'll be your feature, okay? So the combining things is, okay, lastly, this tends to happen and people freak out. So you might see a CSV, right? Where you see something like this, where there's a list of things, strings. There are multiple categories. This process is very similar to one hot encoding, but it's multi-label, right? So you will have multiple ones. So AI tutorial, instead of just one hot where one is one, everything else is 0, you'll have multiple ones. So you create a vector, and there's multiple binarizer, which gets the hashtags and then runs it for you. You get something like this. The code is here. The parts that I skipped, literally, this is the same data set. Just take it and run it for your Jupyter, and I'll post a Jupyter notebook for y'all to use to submit these. Mehdi has either had or will create a lab task for you.
Yeah, we will share lab task first thing tomorrow morning.
Yeah, so do you want them to submit both after your lab? That's okay with me.
Yeah, we can actually have it both submitted tomorrow night.
Yeah, that sounds good.
They also can have the time to like take a while to understand what's been happening today during the lecture.
Sounds good. So what you're going to do is take the data set that I gave you. It's very simple. All the things that you've done so far and these last few columns, just run the code on your Jupyter notebook. My lab task is just that. Okay, any questions? Ordinal encoder. Look, let me show you something. So I will show you ordinal encoder, but also just come here and I will add the link here. Let me paste the link for you. You can go to this and it has the codes, but let me scroll up for ordinal encoder. Yes, we will give you more time for tomorrow's lab as well. That's a fair. You'll give you, I don't know, like 3 days to run things. You will have enough time to watch the video.
You will always have the full description of the lab task either on the assignment page or on the GitHub page. So don't worry about that. And we are gonna give you enough time to work on it.
Okay, then have a good time. This is a really important session. So try to go through the slides. I'll add the slides to the page, and I'll see you. I'm not gonna come tomorrow probably. So Mehdi will teach you no, I actually probably will come for the first 30 minutes, an hour. Mehdi will teach you this recording, post it tonight. It takes time for me to post because I have to edit and make a thumbnail. So by tomorrow night, I promise to submit it. Is that okay? Yeah. We don't have copyright problems, so I'll submit this by tomorrow morning or night or something.